Hello out there, shopkeepers and do-it-yourselfers out there in YouTube land. Today I'm going to attempt to teach you how to check a simple circuit, electrical circuit, and how to use your tool to do just that. And a lot of people don't understand electricity in this way. So I'm going to try and demonstrate through a little lab that I've set up here. And I want to talk first about the tools that we're going to use. This is a typical test light. It'll work on 6 volt or 12 volt or 24 volt. It doesn't matter which way you polarize it, positive or negative, negative to positive. When you make a connection and you've got voltage, you'll get a light. This is called a yes-no meter. If that light comes on, yes, you have power. Yes, you have continuity between there and there. If the light doesn't come on, I'm not touching the post, but if the light doesn't come on, you don't have continuity between your poles. Your poles are your positive and negative. If the light comes on, yes. If the light don't come on, no. This is helpful, but it doesn't tell the whole story. The other tool is a voltmeter. This is more than a yes-no meter. It does say yes, but it also tells you how much. It will tell you, I don't know if you can see it, but I'll turn the light on maybe. You can see at 0 volts. We'll touch the positive and the negative terminals. This battery's got 12.5 volts in it. So we know not only yes, but we know how much. And it also has a resistance meter, volt or an ohm meter. Ohm is resistance. And so let's get right into it. So we have a circuit that we think is not working. And we're going to call that circuit this headlight. We've got a positive wire connected to the battery, and this is just a 2-post headlight. It's a 4651 bulb. We've got it connected to one terminal, and then the ground we've got connected to a starter switch, starter button, and to ground, so I can control the headlight circuit with my starter switch. So when I push the button, we get the headlight, so we know that the circuit's working. However, if you didn't know this, check this out. We're going to hook this to ground. Check, make sure we got connection. Yes, our yes meter's working. I can check the positive side of the headlight, and I've got power. Yes, I've got power on that terminal, but I also will have power going through the headlight. See, my yes meter is indicating that I have power. So I would have power on this wire, which is actually my ground wire, all the way up to this switch. I would have power going all the way through the load. Whatever your circuit operates is called the load. This, you will have power going all the way through it unless that load is bad. You would have power going all the way through up to your switch. So somebody might take their car into Radio Shack to get a radio put in their car, and some electrician, some installer might say, well, I need a power wire. So he's going to take his yes-no meter, and he's going to, well, this wire right here, this is really accessible. So I'm going to take and I'm going to check and see if there's power on this wire. And he's going to poke that wire with his yes-no meter. And see, there's power on that wire. See it? There's power on that wire. So he's going to take his scotch lock, you know, them things that fold over and pinch the wires and rob power. So he's going to take his scotch lock and he's going to take the power wire for the radio and he's going to scotch lock it to this wire right here. But this is actually not a positive wire. This is the ground wire. And I'll demonstrate that by closing the switch, and we'll leave this on there. See, when I turn the headlight on, I'm going to turn the switch on. Now that power goes out. What's going to happen to your radio when you turn the power on the radio and you got the tunes and you're jamming along to Merle Haggard or whoever, and it gets dark. So you say, man, I need some headlights, I can't see. You turn your headlights on and your radio goes out. That's not going to work. Let's demonstrate that right quick. Here is your radio. This is your radio. This light right here is your radio. We're going to take the power and let's see. Hang on a minute. Okay. Well, I think I've got it set up. This is real dim and this is bright. But you're going along and it's daylight, you can't really see that your headlights are on, but you got your radio blasting. You got the bird dog on, you're listening to what's his name? And radio's blasting loud. Now it gets dark. And Steve Earle, that's who I was trying to think of. Steve Earle got the radio blasting and the bird dog on. Now you go to turn your headlights on. See what happens to your headlight or your radio? It goes out because this wire is not a power wire. This is not battery voltage. It is the return side or the negative side of the circuit. So you can't just do that. You need to confirm that the circuit that you're trying to wire to is actually battery feed, because you wind up going through another circuit. So let's take this back away. Let's get all this out of the way. So we're back. We just got a wire going from the positive to one side of the load, and then the switch going from the other side to the ground. So then, everything is working good. But we're going to take and read this battery voltage. So let me take put that on there. See that we've got connection. Okay, we got connection. Turn the light on. Hopefully you can see that. So we're at 0 volts because I don't have anything connected on the positive side. Here's the positive cable. So I'm going to touch this side of the load. That's the battery side of the load. We got 12.4 volts. And over here, we've got 12.4 volts. And all the way up to the switch, we're going to have 12.4 volts. Now, right here, when you when you close the switch, that gauge, that meter should go to 0 volts on the ground side. It's at 12.4. I'm going to push the button, you see? It goes to 0.14 volts. That's good. You want a half a volt or less. And this side over here, it's got battery voltage on it. I'm going to close the switch, turn the lights on, and that voltage drops 0.4 volts. It goes to 12.04 volts. Release it, and it goes back up to stagnant. That's not the word I'm trying to think of. Anyway, like idle, no load voltage. If when you close that switch, that voltage, let's say it drops down to 6 volts. Watch this. we're going to take this load, we're going to pretend that we have a short. We're going to take the battery cable and hook it to this light, and then we're going to take this wire and connect, so it's going to be in series. It's going to be in series. So, let's see, make sure we got, okay, we're connected. So here we got 12.4 volts. There we got 12.4 volts. There we got 12.4 volts. And there we got 12.4 volts. That's great, right? Now look, when I close the switch to turn the headlight on, this is the one that I want to turn on, but we've got a short in the wire. We don't know that. We think, hey, we got 12.4 volts. This circuit's good. Yeah? Well, push the button, close the switch, and instead of 12 volts, you got 5.3. We have got a 7-volt drop somewhere in this circuit. Now, we're going to check the ground side, and we've got 0 volts. So we know that the short is not on the ground side of the circuit, it's on the power side of the circuit. So, look at here. You got 12.4 volts, 12.4 volts, 12.4 volts. So with the switch closed, you see both lights are now sharing the voltage. So it's cutting it in half. Your work is not near as good. So with it closed, we got 5.3 and we got 5.6. So you add those together, you've got, what was that, 11 volts? Well, if you go up here to the battery with the load applied and check the voltage at the battery, you got 12.2. So we got 12.1 there. So we know that our drop is not from here to there. Our drop is from here to here. You could actually take this wire and check your volt drop right there. That shows that we've got a 6-volt drop right here. And that's at 6. So, if when you are diagnosing your system, whatever it is, a headlight, a blower motor, a relay, and it's not working, you want to find out why. See, we should be back to battery voltage. We're back to battery voltage there and through there again because the switch is not closed. We're going to close the switch and the voltage stays at battery voltage here on the positive side, which it should. And on the ground side, it goes to 0.13. It goes to almost 0. That's the way it should be. So when you've got a circuit that's not working, if you go to the ground side of the circuit because your power feed, it gets power live from the battery, so you have battery voltage, and then your switch is on the ground side, say your ignition key has to be turned on, and then you have to turn the switch on. So we'll pretend we turn the ignition key on, ding, 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 and now we're going to close the switch. That's how you have to get the ground circuit to function. You're always going to have power on your ground because it's going through the load. It's going through the load. It is a closed circuit. Now I said all that to say this. I have a motorhome behind me that after sitting for about 4 months, it has decided that the front leveling jack will not work. Okay, I've got just using my yes no meter, and you can see that yes, I have a good ground on my meter, and I'm connected. I'm touching the post on the solenoid, which is just identical to this. So we have battery voltage to this terminal right here coming from the battery, and then we have another wire on there that's going down that feeds all 4 of these red wires right there. And what happens is this wire goes from here to the motor on this pump, and how it's controlled is the panel on the inside the RV energizes this and turns the pump on, and then depending on which button you select, it energizes one of these solenoids or control valves. So then it allows the pump pressure to go through one of these 3 circuits, this one being the left rear. I don't know if you can see that. Let's see. Let me raise my, I think you're out of the viewfinder. Maybe you're in there. This one is the left rear jack. That one's the right rear jack. And that one is the front jack. And I know this because I can follow these hoses. So, now remember how we demonstrated on the headlight that I know that I have power on my load. Let me check my light again. Okay, we still got power. So I'm going to check for power on, I got power on that side, and that is connected to a red wire. So I know that we've got power on that circuit. So that is the battery feed circuit, side of the circuit. And this is the ground side. And there is no voltage on that wire. No voltage on that wire, but we have voltage. See my yes meter? It has voltage. But that one doesn't. That's on the ground side, so that coil in there is open. This should have voltage going through it because it goes down through this purple wire up to the controller, and it would have battery voltage on it up until the switch is closed. But it is 0 volts. My yes meter is reading no. So I need to find a new switch or a control valve to replace this one, because when you push the button for the motor to raise the front jack, you can hear the pump running, and it's squalling because it's building pressure in this manifold, but it's not coming out this hose going to the front jack. So for a quick refresher, got everything hooked back up. Our yes meter is showing good. We've got continuity. We're testing on the positive side of the circuit to the load. We've got yes meter. On the ground side of the circuit, we have continuity through the circuit. The circuit is live. Now, when on the ground side, when I close the switch to turn the headlights on, the headlight comes on, and the yes no meter, the test light, goes out. That's because the battery voltage or the voltage reading on the ground side goes to 0. And should this light stay dim and this light not brighten up as bright as it should, then it is because you have like a load, a short in the ground circuit. You could have, just like we demonstrated on the power circuit, when we put another load in there, it could be a short. A short is a load. Let's say you got a green wire that maybe it's been rubbing against the frame and it's kind of shorting out. You will have a dimmer light, and you will have a positive voltage reading on the ground side of your primary load, and you would want to go from there back in your ground circuit to find your short or your unintended load, like somebody wired in a radio or some sort of stupid interior light. But that is a quick way to test your circuits. Of course, there's ohms and amperage. Amperage is the work that it's doing. It's how heavy is your wheelbarrow? How much energy does it take? How much force does it take to move that wheelbarrow? This light takes maybe 3 amps. You put in another light just like it, now it takes 6 amps. And if your wire is too small, it won't carry it. The wire gets hot. Your lights won't burn as bright because there's resistance. Where resistance goes up, amperage goes up and voltage goes down. You need to take a look at Ohm's law. That's OHM apostrophe S. You need to take a look at Ohm's law. Where there is an increase in voltage, there's a decrease in resistance and amperage. That's why they can get away with smaller wire on a 24 volt, a 48 volt, whatever volt systems that they're using now. You can use a 22 gauge wire, which is very small, versus a wire that's say 4 gauge or something as big as your little finger, even bigger, as your thumb. You can't use a wire like this, these test leads that I use, or like this to operate your starter. That wire, when you go to hit the key to energize your starter, that wire will jump because of the load going through it, and then it'll get real hot. You can't do that. It might work once, but it won't work twice, and more than likely you'll have a fire. But anyways, guys, thanks for watching. I hope this helps you. Share, like, and subscribe. Comment if you will. By the way, I went to a 3-day course when I worked at Chrysler back 35 years ago, over to Sharon, Ohio, I think it was, or Sharonville, I think it was. I can't remember now. To the factory training center there in Sharonville, Ohio, on the northeast side of Cincinnati. And then when I worked at Chevrolet, I went to Indianapolis, or on the east side. They had it at, I can't think of the name of the college there, on Oriental Street and US 40. I went there. It's called GEMSET, General Motors Special Electronics Training Course, GEMSET. It was an 8-day course, and I thought, man, I'm going to be bored. Well, I tell you what, they turned my world upside down. I learned an awful lot about doing electrical work and understanding how to diagnose a system. I didn't go into a lot of it here. The class was 8 days. I can't cram 8 days into a 10-minute video. But set up a lab and get you a voltmeter and start testing and see how these theories that I've demonstrated to you, how they work. You'd be amazed. And it will change the way you diagnose things and how you wire things. Anyways, guys, thanks for watching. Share, like, and subscribe. Comment if you will.